Everyone, welcome to my online class. Myself, Dr. R.S. Kamalakanan, ASPEC, Department of SVHC. Today, we are going to see the explore of the fundamentals of microprocessor and microcontrollers, including their architecture, programming, and applications. Microprocessor and microcontroller technology have revolutionized the way we design and develop modern electronic systems. A microprocessor is a central processing unit, that means CPU, that contains the entire processing system of a computer on a single chip. Then the microcontroller is the differentiated platform. On the other hand, or specialized microprocessor used in embedded systems such as robots, home appliances, and automatic control systems. Of microprocessor microcontrollers, understanding microprocessor and microcontroller is crucial for designing and developing efficient, reliable, and cost-effective embedded systems. In modern technology, from smartphones and smart home devices to industrial control systems and medical devices. The main applications of microprocessor and microcontroller has a wide range of applications, including embedded systems, robotics, automatic control systems, industrial automation, medical devices, consumer electronics, etc. Concepts in this chapter. The work with microprocessor microcontrollers, one needs to understand key concepts such as microprocessor architecture, instruction sets, programming languages, that means assembly languages using C, and interfacing with peripheral and sensors. By mastering these concepts, engineers and developers can design and develop innovative and efficient electronic systems that transform our daily lives. Then the first part, the functional blocks of microprocessor microcontroller. It having ALU, register array or internal memory, instruction decoding units, flag registers, timing and control units, program counter, and IP. These are all the main blocks in the microprocessor and microprocessor 8086. The ALU having computational units performs arithmetic and logical operations. The flag register having various conditions of the results are stored as status bits called flags in flag registers. Then register array having internal storage of data. Then PC generates the address of the instruction to be fetched from the memory and sent through the address bus to the memory. The instruction decoding performs decode instructions, send the information to the timing and control units. Then timing control units generates the control signals for internal and external operations of the microprocessors. Then overview of the 16-bit microprocessor. It is formed by 1978 by the Intel corporations. Originally, HMOS technology, it is used in the manufacturing process of the microprocessors. It is approximately 29,000 transistor, 40-pin DIP technology with 5 voltage supply. Does not have internal blocks, external asymmetric clock source with 33% duty cycles. Then it having 20-bit address to access memory, can address up to 2 power 20, that is equal to 1 megabytes of memory space. Discuss about addressable memory space is organized into the 2 banks of 512 KB each. One is the lower bank, another one is the higher bank. Lower bank even bank, higher bank is the odd bank. The address lines A0, that specifics A0, is used to select the even bank and control signals. Uses a separate 16-bit address for IO mapped devices can generate 2 power 16, that means 64k address, 64,000 addresses. Then it operates on the two modes. One is the minimum mode, another one is the maximum mode. It is decided by the two symbols MN and MX bar pins. Next one is the pins and signals. And what are the pins are available in the 8086? Totally 40 pin package, that is deep dual inline packages. It having first pin is the ground, then continue second pin to 16th pin, that is the address data. 14 pins connected. Then 17th pin is the NMI, that means non-maskable interrupts. 18th pin is the interrupt request. 19th is the clock signal. 20th pin is the ground signal. Then 21st is the reset pin. Then 22 ready. 23rd test. 24th interrupt acknowledgement. 25th address latch enable. 26th data enable. 27th, that is the serial and parallel communication interface of the data transmitter and receiver. 28th memory input output. 29th write. 30th hold acknowledgement. 31st hold. 32 read. 33 minimum and maximum mode. 34th bus high enable status signals. Then remaining of the address lines starting from 35th to 39th up to 16th address and data lines. Then finally 40 pins connected with the VCC. Bus high enable signals, that means BHE active low means S7 output. The bus high enable and the status is it is used to enable data onto the most significant half of data bus. Then M and MX, that minimum and maximum mode of operations of the processor. Then read and active low signals, it act as the output signals, it is active when low. Then status signals, that status signals mention the S0, S1 and S2. It is operated based on the mission cycles. That mission cycles are interrupt knowledge, read input output port, write input output port, halt. Next one, code access, read memory, write memory, passive, inactive. These are all the operations based on the status signals. Whatever we given the input signals based on the 3 bits level, 000 to 111. That is the mode of operations. That is the different operating procedure of this mission cycle based on the microprocessor. In the maximum mode of operations, the grounded signals logical low. 24 to 31 are reassigned signals of the Q status, QS1 to QS0. The processor provides the status of Q in these lines. Operations of status having the 2 bits of operations. That means no operations, first byte of an opcode from Q, empty the Q, subsequent Q from Q. Are all the performs based on the Q operations of the Q status. Next one, we discuss about the architecture of the 8086 microprocessor. The architecture having the on 2 levels. First one is the bus interface unit. Second one is the execution units. The bus interface units having fetches the instructions, read data from memory and input output ports, writes data memory and IO ports. These are all the bus interfacing units. Then executing units having EU executes the instruction that have already been fetched by the BIU. BIU and EIU functions on separately. Then address, dedicated adder to generate the 20-bit address. That means 4 16-bit segment register having code 1 is the code segment, second one is the data segments, third one is the stack segment, fourth one is the extra segment. For the segment register available, the segment register is the segment 1, 0, 2, 3, 4. Totally 4 segments available in the physical memory spacing from starting from 00 to 840H. That is the hexadecimal of the conversions. physical address is the IP. It is mentioned in the IP, that is marking on the yellow, that connected the internal communication registers. 8086 is the 1 megabyte memory is divided into the segment of 64,000 bytes in each. The 8086 can directly address 4 segment, 256,000 bytes within the 1 megabytes of memory at a particular time. The programs attain access to code data in the segment by changing the segment register content the point to the desired segments. Next one is the code segment registers. The code segments having the 16-bit segments, it contains base or start the current code segments. IP contains the distance or offset from this address to the next instruction byte to the fetched. The bus interface units computes the 20-bit physical address by logical shifting the contents of code segment 4 bits to the left and then adding the 16-bit contains IP address. That is, all instruction of program are relative to the contents of the code segment multiplied with 16 and then offset is added provided by the IP. Data segment register also having the 16-bit address. It points the current data segments operands for most instruction fetched from these segments. The 16-bit contains source index and the destination index or a 16-bit displacement are used of offset for computing the 20-bit physical address modes. Main important of the stack segment register also having the 16-bit address. It points of the current stack. It based on the 2 operating mode. One is the push and pop. The base addressing modes 20 physical stack address is calculated from the stack segment and base pointer. Extra segment having 16-bit address. It also the segment of data 64,000 pointed of the data segment stored. Finally, the string instruction use extra segment and destination instruction to determine the 20-bit physical address for the destination. Then execution units. Next one is the execution units having the 16-bit ALU for performing the arithmetic and logical operations. 4 general purpose register, that means AX, BX, CX and DX, including stack pointer and the base pointer. The indexed register source index and destination index each the 16 bits value. AX is the based on the higher level and lower level components. The higher level is the 8 bit, lower level is the 8 bit. Totally 16 bit value is mentioned on the X. The followed by BX, CX, DX also BH and BL higher level, CH and CL higher level and lower level, DX is DH and DL higher level and lower level. And final processing of the execution unit register is the accumulator registers. It is it mentioned the AX. It consists of 2 8-bit register AL and AH. It can combined together used 16-bit AX. It mentioned the L value is the lower order byte, H mentioned on the higher order byte. Input output instruction execution based on the accumulator register. That means AX or AL. That inputting and outputting based on the 16-bit data or 8-bit data from the input output port, whatever we given the input based on the 8-bit or 16-bit either or. So AX is used for the multiplication and division instruction, very useful, and produce the output in the based on the 8086 model. These are all the 8086 microprocessor functional blocks and architecture of the 8086. Thank you everyone for watching the session. I hope you all of you must know the basic of microprocessor 8086. Once again, thank you all.